In the previous video, we looked at repeated measures or within groups design. Now we're going to move on to another category and look at quasi-experimental research. Now, if you review the components or the features of a true experiment, we know that we need three things: manipulation, comparison, and randomization. To distinguish quasi-experiments, we need to understand the difference between the two. So let's see. First, in a quasi-experiment, the researcher still manipulates the hypothesized cause or the IV. So the first feature is still present. Now there's also both experimental and control groups, and thus the comparison feature is present. However, participants are not randomly assigned. So the third component is not present. Regardless, in both true and quasi-experimental research designs, the researcher still tries to control as many variables as possible other than that which is being studied to still ensure internal validity. Okay, so let's look at the specific design so we can use. So first we have the static group comparison design, and in this case we have the control and we have the experimental group. And what we do here is we give the intervention to our experimental group and we leave the control group, and then we take a measure of the control group and also of the experimental group after. So the only difference here when we go back and look at the randomized two-group design is that this one features randomization, random assignment, whereas in this case, there is no random assignment. Now, what could be an example for this? So let's say you are conducting your journaling study on minors and you need the parents' consent before they allow their kids to participate. So let's say the parents also say, I will only let my kid join your study if I get to decide which group he or she joins. So let's say some parents I want my kid to take part in the journaling group or the experimental group. Whereas some students say, no, just don't make my child journal. I think that's going to be distracting. Just put my child in the control group. Okay, so automatically that means that you won't be able to randomize the assignment of your participants, and so it would probably be better for you to just adapt a static group comparison design. Okay. However, again, because of that, you obviously will have problems with your selection bias, right? Because that's what randomization is trying to control. So what if a lot more of your better students end up in one group versus the others? Okay? So what if, for example, the parents of those in one group are also the parents who've taught their kids to not choke during a test? So of course that will be a problem because you wouldn't know, was it journaling that reduced choking or was it something about the quality of your participants in that said group? So to answer that problem, we may use another design, the pre-test, post-test, non-equivalent groups design. And in this case, we still have our control and our experimental group, but prior to the intervention, we give our students a pretest. So we give both of them a pretest, and then in one group, intervention will be administered or given, and then the other group, no intervention will be given. And then afterwards, you are going to test them. Okay, so post-test to see whether there's a difference. So at this level, you will be able to compare their baseline, and then you'll see whether this group is better already or not. But then you can also compare how much is the difference between the pre-test and the post-test versus the difference between the pre-test and the post-test of your experimental group. So ideally, if your intervention is effective, there should be a greater increase in the scores of the students in the experimental group. Now, another design we can use is called the interrupted time series design. Because if you go back here, now let's say there's an increase in the post-test of both groups. We have to ask ourselves, is it because of maturation? So remember, there is also the issue of maturation. So maybe both groups just, perform better through time, because that's generally what happens to people through time. So what we can do here is we can instead put a additional set of measures. So what we can do is test people. So we have observation 1, observation 2, observation 3, and then we give our intervention, and then make observation 4, observation 5, and observation 6. So here we're adding more observations. So we test them multiple times before giving the intervention, and then we test them multiple times after. So let's say you acquire data, and your data looks like this. So their scores slightly increase, but then between the third and the fourth observation, there's quite a steeper increase, and then go back to the slight increase after the intervention. So what that seems like is that if you look at this pretty steep increase, there's a difference in the rate of increase. You can assume that this is from maturation, while this is something that has been influenced more by your intervention. Okay, so especially if the rate is very consistent, then you could rule out the possibility that the increase is due to maturation. So it's probably something more than that, because the rate of increase is bigger, especially during this time. Now, if you're not sure of that, what you can do is use the replicated interrupted time series design. And I know it sounds a lot more complicated, but let me show you this. So you have observation 1, observation 2, observation 3, and then you have your intervention. And then you make observation 4, observation 5, and observation 6. So what if you want to figure out, is that really the intervention? So we add a control group. So for our control group, we're going to make observation 7, observation 8, observation 9, and then we are not going to give an intervention because it's a control group. And then we make observation 10, observation 11, and observation 12. So 12 observations all in all. So let's say for this group, you have this slight increase in the scores, right? And then after, there's a steep increase. And then you go back to the slight increase after the administration of your intervention. But let's say we compare that with your control group. So this is your control group. So let's say we have something like this. Oops. Wow, look at my lines. They're so straight. Anyway, I think you get the idea. So let's say in your control group, you have that. So as you can see, from this point to this point, it's quite steeper compared to this one and this one and this one. That's not so much. Okay, and that's for your control group. So you could probably account this one as more because of your intervention, and this is probably more because of maturation. Okay, so that is the beauty of a replicated interrupted time series design.